Papa Bale. I just want to show you how excited my gyro scope is. Got the outside spinning real good. And the inside is spinning real good too. But now we need to get some power to it. So we kind of want to discuss different ideas for commutators. Basically to get the power from here to here without tethering with wires. Oh yeah, I'm gonna chill just for a little bit. You can get up in there and show them what it's all about. All right, so there's two ways to build this. Kinda. There's more than two ways, but like it is, there's two ways to build it. You can either have the magnets on the rotor in the middle, or you can have the magnets on the outside and have the coils in the middle. I'm gonna attempt both kinds. I'm pretty sure that my big one is gonna be with the coils in the middle. It's gonna be an aluminum rotor. And I'm thinking I'm gonna use, magnets that aren't as strong as I've usually been using. Like these right here. I'm gonna use these. Like a stack of these for my magnets. Yeah. The deuce, deuce, deuce. So for a commutator, since I was actually thinking about putting reed switches or one reed switch, start with one and then see if two works. But I think once we get past one, it's going to get a little tricky with reed switches. We'll put a reed switch, glue it right to the side of this coil right here. Get the power to flow constantly through the commutator. We're not looking to break or switch with our commutator. We're just looking to have it pass the power on to the gyroscope without needing to tether it down. So we're just looking for a way the power to get to it and have the coil spin like that. And the commutator is a good way to do that. And I've pretty much proven that that you can just glue it like this and then spin it, and if there's power going to it, it will make the rotor spin the other way. Thank you. Really appreciate the like. Thank you. So you get the commutator, you get the power up, you do a series circuit. You get one reed switch on here and tap to the positive commutator. You're going to have two rings, two separate rings that aren't touching each other down here on the base. Okay, and then all the brushes are going to touch the respective rings, positive and negative. And I think that if we do a series, we only need two brushes. We do a series circuit. And since this is just a toy, I don't need to go. I mean, I could do it, and I probably will end up doing it, having a parallel circuit, in that case, I would probably use the commutator as a switch. But if it's a series, then I just put a reed switch right here. Use a commutator as like a, what would you call it? It's just basically a connection, basic connection. Like if you just have a solid copper ring, when power going into it, and then a brush touching it and not removing itself, you know, just continue to touch it as it spins. Just always touching it. No break, no separation. And the power is always flowing, and then the reed switch will work. It'll work. And then you spin the gyro this way. And the cool part about it is when it engages the rotor and it starts pushing the rotor that way, each time it does that, it pushes that way more. Pushes the other way more. So it'll continue to do that until it reaches the voltages max. When you put the voltage into the equation, that max, because there's a whole other part of the equation where these are opposed, that is increasing speed. But you know, that's all, it's constant with this thing. That's a constant. That happens regardless of anything else. I mean, it's constant. Because I've demonstrated that just with the reed switch. I put it up in here and it'll try to push that way as it forces the rotor to move that way. I've done that with it tethered, and it's like trying to move the other way. So I mean, I know that happens without any Bedini schoolgirl stuff going on here, just with the reed switch. Although all that stuff might be, you know, cool, we might do it on the big one. This one's a little small. We're going to keep it simple. But we're just waiting. I'm waiting for my copper to get here so I can make my brushes and my commutator rings. Oh. We'll give it a little test run. Currently, we don't have the commutator ring, so the gyro won't be spinning, but the rotor will be. I'm running it as a motor currently. When I make the commutator, we can change it up a little bit. All right. Whoa, okay. See it? It's pushing. You see that? Now, if it wasn't tethered down, that'd start spinning, wouldn't it? Yeah, it would. Heck yeah, it would. It'd start, and it would get going pretty fast, wouldn't it? This is a gyroscope pulse motor at the moment.
What's up, Giga Chad?
What's up, my brother? You see, all the gyroscope wants to go that way, and the rotor's going this way. And I'm not touching it. I'm not pushing it at all. That's all magnetic flux or whatever you want to call it, making it want to go the other way. Heck yeah. Thank you. Yeah, man. I want the commutator to work at that speed, you know? So let me give you the concept of
Welcome there.
hey there, millionaire. what the brush is going to function as, since it's going to be continuously in contact. I hope that'll work too.
Chad asked what the light does. Germany in the house.
That light?
Which light were you talking about, Chad? One on the switch.
Oh yeah, it's an indicator light. It just shows you that it's switching.
Yep. So that means it's active and working.
And it shows you every time that it pulses when it's not really blinking right now because it's pulsing so fast. And that's a single coil. Awesome.
Very cool.
That is 24, that's 25 volts in. So it's really responsive.
Picking up some milliamps.
Yeah, 300 milliamps, maybe 350. God, I wanted to make that so bad. I'm like, I'm anticipating getting the copper. How many watts? Let me think here. Less than 2.
Multiply these together.
Oh yeah, yeah.
That would have been 7.5.
7.5 watts.
At the 0.3.
Yeah, 0.3, 7.5.
That I'm not sure about, Chad. Don't have any experience with old engines.
See, now it didn't move when I untethered it because the actual force of the reed switch, and it needs the commutator, but it'll start spinning pretty freaking awesomely. Hell yeah, I can't wait, dude. It's going to be so awesome. And it's going to be built like counterintuitively to the way that it should be built, I think, because we're going to put a reed switch in here. I think I might need to buy a solder gun. Now that I'm thinking about it, I might need to get some solder because you put I've been trying to demonstrate this, looking for something that I can demonstrate it with.
Yes, it's definitely 3D printed. There's a machine. And all of these are 3D printed.
I don't know about anti-gravity. It might float. It's supposed to be able to float. People say it can float, but I don't know if it's going to float or if it's going to change time or anything like that, but it's supposed to.
What kind of converging art on that one?
All right, so this is the brush that's going to hang down from the coil, right? But it's supposed to hang down like that, and maybe even have a little weight on it like this so that it stays down and in contact with the ring. So, and it can even be a diode. Why couldn't it be a diode with the power going one way and the power going the other way? I mean, it could be a diode. Very
Hey
much.
everybody, welcome to the channel.
Hey, what's up?
Like and subscribe, drop a comment if you're interested in pulse motors. We are working on a gyroscope experiment.
Oh, yeah, this is like the biggest rectifier diode I could get my hands on. And yeah, that'd be sweet. Just get it down far enough, have it like angled off like that, and have a little tiny like magnet on here just for holding it down. So when it spins, it stays down.
And Giga, applications vary, and we are.
I don't have an end game, man.
Yeah, I'd say it's more passion right now.
Yeah, there's no end game. It's not like I'm going to talk to Elon Musk at the end of this and we're going to go to Mars together. It's not going to happen. I mean, well, it could happen, but I mean.
But coming into this without any background, it's quite a learning journey on the channel. And feel free to take through some of those. There's been a couple of catastrophes on live camera too.
Because I mean, after I maglev this thing, it spins like a champ, dude. Pretty good for how much drag there is on it. But the application is, I don't know. I feel like it's a challenge. I've never seen one of these ever, anywhere. I've never seen a built one in my life. I've seen a side picture of one made out of wood, but that was like something from, you know, the 1970, early 1970s or something, maybe earlier. Since then, I'm sure people are building these things all the time, but I haven't seen them. And I definitely haven't seen, I mean, my friend and colleague 007 said that he had a working gyroscope that went about 3,000 RPMs.
Nice.
I don't know if he built it or not, but he said he has one. So I know they exist.
Yeah, definitely look out for his comments. And
I think this is called zero. What it's supposed to be is zero force point, but this is not that. This is just a prototype, a small framework demonstration of how I'm going to build it. I'm going to start building the big one when the pieces come. But I think it's called zero force point.
appreciate that, Giga.
Thanks, Giga. But it is a gyro, and I think that means that it spins in multiple directions. Yes, sir. Thank you. Thank you. Thank you.
Thank you.
What's cool is that all this is uniform. I mean, the magnets are the same, the coils are the same. Everything just seems to be falling into place to make this work. I hope we can do it. I mean, the best info that I got, there was a picture that was a really bad picture. Hey, Giga, yeah. Thank you, sir.
Appreciate the super Giga.
Yeah, thank you. And then we will indeed.
How many RPM? We haven't set up a piece of
Tinfoil on that yet, but we could probably divide by 6, right?
Oh yeah, with the magnets themselves. Yeah.
Yeah, let's do that. We'll hook it up, and this is a 1 coil. 1 coil demonstration of the speed at 24 volts. Do we have the tach?
Right here.
All right, sweet. You want to do the reading?
Sure.
All right, let me crank it up.
I'm not sure I know how to use this.
So 5,573 divided by 6.
That's going to be right around 900 something.
Okay, let me do it again. 6,373.
Yeah, that's 100.
Over 1,000.
1,050. That's what it was. 369 theories from Tesla.
Is that for this experiment?
He's asking. He's asking.
I didn't apply that, but if it's for this experiment, I probably should.
RPMs are above 1,000 right now.
Yeah, 6,101.
And that is
About 1,000.
yeah.
For one coil, we're getting about 1,000, and that seems to be like my limit on the 1/4 inch. 6,693.
Yeah, that's 100.
All right, so we're moving it right around the amount of turns we have in each coil. 1,111.
And very smooth. And 11, I was trying to, would it be 11D 11?
11D 11, 1,000. Yeah, probably. And then look, I mean, it's got flywheel capabilities. No, it doesn't, but I mean, like it'll go for a little bit. And you know what I owe it all to? The shaft is micron smaller than the bearing, so it's a buttery smooth fit. It's like they were made for each other. But it's like so. The only friction is happening because I'm touching it.
We really appreciate that, Giga.
So thank you so much.
Agreed.
Yeah, man, I love like getting my hands on it because, well, I don't know how other people feel about this, but they like to go at it from the back to the beginning and work their way back from the end. But I always like to start at the beginning and
just engineer it.
Work my way to the start and fix the bumps as I get to them. And I feel like it enriches me somehow to not have it all planned out.
Right, and to learn real fast.
Yep.
Pretty cool, man.
Yeah, this just happened to be a spectacular. It's a little crooked, but it's not going to hurt its performance, which is, I think that's really awesome. You can't tell really, even just by looking at it, but this bottom part, there's a metal piece that I put in, and it's a little tiny bit lopsided. It's one of the bearings on the bottom part. So when I put it on, I got to move it a little bit to get it on. So, but I'm happy with it, how it came together. And it's like a top too. I can just spin it like a top, literally like a dreidel.
Yeah, and then he printed these first, and then each individual spoke, because they couldn't do more than 2 at a time. We're working on that, and then the caps for the
one at a time.
Couldn't do more than 1 at a time.
Right. Every time I add an extra one, hey Peter, what's up, my man?
There as
Peter, you gave me a great idea.
say it.
Yeah, man. No, I mean, like the coils on the inside, man. I think I'm gonna do that for my my Primo build.
There as how many windings does one coil have?
1,111 per coil.
And then where did you get the power device?
From Amazon. Your standard online distribution center. This is a 25 volt, 20 amp power supply, and this is a 60 volt, 8 amp power supply. All right, let's talk commutator. Yeah, man, that's great. The coils on the rotor, it's definitely something that I've been thinking about doing, and I think it's a great idea because it'll keep everything kind of together and real compact. And it'll keep it all towards the middle, which would be more like Rodin and his coils and whatnot.
Hey, buddy.
Hey, buds. How you doing? Come on. Come on up here.
Cool. We got a peanut gallery.
So what I've been thinking about doing is hooking up the 60 volt power supply, since when I hook up all 6 coils in a series and you got 6,666 turns altogether, putting more voltage in, because you don't draw like even 0.1 amps. Like rarely you'll draw 0.1 amps on that at 24 volts.
Ooh. Yo, look at that.
Oh, we gotta blow that back up. All right, right there, right there. Then put the magnets on the things holding the coils. The coils. Wouldn't that be a don't? It's hooked up like this. Okay. Generator, an axial generator. Or is that's magnets on either side of the coils. So it'd be the opposite, or like a negative inverse of an axial motor.
Now we're getting some confidence.
It would be, instead of having the magnets on either side like this, you'd have the magnet in the middle and the coils on either side like that.
Yes, you got it, Ted.
Yeah, it is. Very much. I mean, it made another 6 pop up on this.
It did.
When it wasn't even hooked up. You know, it's like
the video is a couple days back.
Yeah, crazy. It's like it wasn't spinning and you were getting 6 volts. How did that happen?
Ooh, iron core question.
Yeah, I have some ferrite cores coming that will fit in these holes. I thought about that. They're 3/8 diameter, and but they're 2 inches long instead of 1 inch. So
See if I can see it. There's one right here.
No, they're smaller than that.
Oh, okay. Small cores. Got it.
Yeah, they'll fit in these ones.
Oh, excellent.
What did I just say? What are we proving, Peter? I forgot.
They're asked if the iron cores add to and strengthen the magnet force.
Oh, hell yeah, by 4 times is what I heard. 4 times the magnetic flux. But I guarantee that you will have to spin it a certain speed for it to even move with cores in this thing. And the fluidity of the motion will cease to exist.
What's up, Ted?
Ted, hey, what's up, man?
It is a cool name, Peter.
Yeah, it's great. 2.0, you know, instead of like junior, it's like 2.0. Benjamin, welcome back. Yeah, I made a 12 point and a 24 point. I think it was 36. I'm not sure which one it is now. It's been a while.
You can check out the video in the library there. It's awesome.
36 point. I think it was a big one. It was a big one. It wasn't a 3D one, but it was a flat one.
Totally cool. We are coming at this without any background, so we're learning in real time. We appreciate all inputs.
Yeah, we're trying our very much our best to be safe and conscientious of everything that we're doing here.
Who do you want to show? Gyro, get it spin in the other direction.
What?
The rotor.
Yeah.
Were you talking the rotor or the gyro?
Watch this. Watch this.
What's up, Jacob?
Hey, Jacob. Welcome back.
Right.
We'll get it going nice and fast.
Benjamin says the 3D has to be one of my favorite with the helical chloride path.
Right?
Check out your. Thank you.
Thanks, man. I am a fan, though. I like Vortex math. I really do. 369 definitely plays a part in Vortex math.
Here it comes. Check this out. It'll. Oh. That's just for moving it on the other side of the coil.
So to answer your question, yes. And if it starts spinning in the opposite direction, the gyro will spin in the opposite direction because it's the force of the rotor pushing off of the gyro that makes the gyro spin in the opposite direction. The force of that push is debatable based on how you wire it, and that's a fact. If you can get all the schoolgirl circuitry in here and work with all the spikes and everything, you can definitely get a stronger push than just this reed switch, I'm pretty sure.
Ted dropped a VLCD motor. Okay, so he is aware. Does this fall into the classification of a VLCD?
Yes, they are Neo Mags and 52s. Thanks, Chad. Thank you. M52s. There are 3 disc M52s, and then there's one 10 millimeter by 10 millimeter M52 on the outside.
Thanks, Dad.
So yeah, you see how fast it moves at 25 volts, 0.3 amps at like 7.5 watts. It's moving at 1100 RPMs. And the cool thing is that I put it all together with double-sided adhesives on the top here, so I can just, that'll all come off. This will come off nice, and I don't know if it'll be easy, but it'll come off. It's pretty strong.
All right, we'll check it out when it's done, Peter.
All right, Peter, are you making the core video now? Oh, that's all right. I'll check it out when you make it.
Yes, short.
Thank you. Thank you. I think those, I'll put the ferrite cores in here when I get them. Just to see if the performance improves. No, it won't break. You just have to untether it. Make sure it's not connected to anything. Well, usually you have to take it off a piece at a time, but I'm not going to take it all the way off without doing that. But look at that. Look at that. Woo! This thing, if it can fly, it will. Seriously. I mean, it is kind of heavy, but when you think about it lifting off.
Thanks, Benjamin.
Thank you, Benjamin.
Nice. Hey, B-Bob.
B-Bob? No, just something that spins really fast. We're looking right now. It spins 1100 without the gyro.
And yeah, the rotor is about 2 millimeters above bottom. Is that correct still?
The rotor?
Yeah.
Yeah, right here. It's only.
Oh, it's about a centimeter.
Yeah, it's higher now.
Yeah.
That's good.
Yeah.
And it still levels off with the coils, I hope. Yeah, like right in the center.
Great question there.
Will it affect the balance if you put cores in? I don't know. I think it will latch the rotor if it's not going fast enough. You know, the rotor will move in sync instead of anti-sync.
Yeah. Search through our videos for catastrophic failure.
Yeah. Yeah, I am not really worried, but these magnets on the outside could fly off with inertia, but the ones inside, I'm not even worried about them at all because they're caged in there. I mean, this is a gyroscopic, so it'll be moving like probably more than double the RPMs that it was going now. So safety might be a little bit more safety might be might be called for. I like one electromagnet being stronger than the other.
So that's with the cores.
Oh no, they're the same amount of turns. It's going to be as balanced as it can be. The cores, I'm sure if they're all 2 inches, it's going to be more of a benefit than a hindrance. Woo!
Woohoo!
Yeah, these are nice and strong for what they are. They're a little thin, but they're nice, and you get a good stack of them together. I'm already thinking about the next one. I haven't even finished this one.
If it was for BattleBots, yeah, wind energy generator. Nice. Here, let's oh, this one.
Oh yeah. Dude, I could get my shop vac right now and show you this one. I don't know. I felt like I'm sure other people are doing this right now too, but I felt like I needed to make pockets for the air to get caught in and then filtered out through the bottom down here on these holes. But the holes weren't big enough. It's just a prototype, but the idea is pretty sound. And it's not a hydro, it's a wind.
Yeah.
Yeah. His was a little different, and I believe it was for viscous fluid that his was made. This is really for air, not a hydro turbine, or maybe dirty air. You know, dirty air could probably run his hydro coil hydro turbine pretty good. Steam? Hell yeah, I'd love to run this thing on steam, but only it would probably melt. Or is that stem? Oh, you mean the hole down here is good for steam? My God, that would be awesome. I don't know. But I do know that when I hook up my shop vac backwards and I pump the 2 horsepower wind through this thing, it whips.
Oh. Oh, you're good. You're good, Jeff.
You're good. You meant steam, right? Like, woo-hoo, steam? Or did you mean STEM, like electrical shock therapy? You know, I kind of want to run the other setup. I'm glad you found that funny. That's all right. Let's see here. Go 15.6, 15.8. What the hell?
Trying to start.
No, there's something wrong with this. I don't know what it is.
Nice.
I think 16 will be good. Should be good. Oh, there it is. There it is. Haha, it's great when you find out what's wrong so fast.
Put him off.
Yeah, of the ground for the trigger coil. Now let's see here. Oh boy, here we go. There it is. Look at that. And that's up to speed in less than 20 seconds. Because I'm using 16 gauge coil for the drive. So there's 2 perpetual loops. Nice. Awesome, man. Well, they're not perpetual. You know, you have to have that motor running for them to work, but they're continuous loops. We'll call them continuous loops. So we're running 2 pulse motors. One pulse motor is being run off of this coil, which is 18,000 turns of 32 gauge. And this one's being run off of this coil, which is 22,000 turns of 32 gauge. We'll let that get up to speed.
Yes. I see three of them going at the same
I feel like this one can do better. I do. I feel like it can do better.
time. Yes. What is the goal idea?
Of which one?
Yes.
The goal RPM. Let's see what it's going right now. I think 300 is the goal for me on that one. This one's going 750. And that's look at the shaft shaking. That's pretty much all I want to do with this. It's about 750. And I guarantee that'll get going about 250 before it.
But it's
Yeah, that RPM. This rotor was at max speed 15 seconds after I started it or less. 783, 784, 785, 787. But it's because the shaft is shaking that it's only accelerating slowly.
interesting question.
790.
How energy efficient? Are there more or less energy than a normal electric?
I don't know the specs on a normal electrical engine.
Oh, Peter chimed in.
50%? What does that mean?
More or less.
I'll be right back. All right. Is he peeing?
Yeah.
Hell yeah. Oh, fucking yeah. I had to drain the main vein. All right. So, man, I had something when I came out. Fuck. What was it? Oh, about commutators. I can do a permanent commutator, right? It doesn't have to switch, does it?
That was a naked gun. But come on with the beginning there with an install, dude. We have stated that we're coming in this with no background, sir.
Oh, he's talking about the mic in the toilet.
You said get some school.
Oh. He's talking about the mic. Yeah, you can get him real. That's fine.
Oh, got
He's not talking about the project. He's talking about the fact that I had my mic on when I was taking a leak. But I appreciate it. All right, back.
Super caps. You got super caps.
Super caps. I do, but they're big. They're right here. Now I have these little tiny caps. The blue ones are super caps. They're 200 or 2.7 volts and 500 farad. So that's like 500,000 microfarad. The project is man, it feels so like I left my mic on in the bathroom. That's funny. Oh, that's awesome. That is Naked Gun, straight up. I took care of my dinghy at the press conference, man. Hey.
Peter says it was loud. So yeah, it was yeah.
That's a 50 volt with 0.23 microfarad.
The mini cap.
So this one, the 50 volt one, will fire all the time. Like there's no capacitance in it, but it's definitely a 50 volt capacitor. And then this one is, 2.7 volts with 500 F. I don't see how this one will fit on that. It could fit on the base, but I don't see. Maybe the little one for sure. Little one packs a lot more power. Well, it packs a lot more voltage. It doesn't really have anything inside of it, though. So cool. All right. So do we recommend doing a parallel circuit on the gyro, or does it matter? Can we do a series circuit and just have one connection to the base? I'm gonna give everybody a chance to unwind. Just put that on the ground. That's all right. Or I'll move it.
This one. Right here.
Oh, there's one that I want to see here.
Still don't understand what you're doing.
Um, I don't know what you're getting at, outsider. Use your imagination, homie.
Okay. Is this the new video?
Yeah, he's been.
Oh yeah, and art or in the background.
All right, so let's hook this multimeter up. I'm dying to see the wave of these little coils, if there even is a wave. So we'll hook one to that end. And we'll hook the other one.
Guys, Peter said I got my phone to do the McDonald's wave like yours did.
Nice. Which McDonald's wave?
The coil.
The generator coils? Yeah, I'm asking him.
When I put iron core in the coil, it made it square wave. Ooh, late night.
Wow. That's awesome, man. How many days have you gone without sleep, bro?
4 hours.
That's awesome. I get some. I stay up occasionally, though. All right. So this is what we're gonna do. We're gonna go from the same coil and we're gonna get a voltage reading and an amp reading and a sine wave reading. From this little coil. Man, that's the brakes, man. Forget to take your mic off.
My bad. Yeah.
You lost likes on that one, bro.
It was an embarrassing moment.
You heard some hell no's going on. Like, how could he forget that? Oh yeah, I gotta plug in the power now. Let's get this one over here.
So Peter is very resourceful in finding pieces to work with old electronics.
Yeah.
We just made a video of using a cord that he got from the inside of an old car.
That's awesome.
Excellent there.
All right, man. All right, we're doing AC all around. Power on. Connect and connect. Up we go. And up, up, up we go. Into the Tesla Cybertruck.
Computer monitors are better for it.
Oh no. Oh, that's what it is. Okay. Dude, that's not cool. There we go. I just had it hooked up to the wrong one.
I'd never heard that one before, Peter. I've heard it's beer 30. I've heard that one before. Somewhere.
So we got 1.3 volts off that coil. 1.4. No amps though. Maybe we can get some micro amps.
I've never used it though. I've done some really weird things to people. Like if it's like 815, I'll say it's 775. Black.
So 1.5 volts
I got it.
and no amps. Oh yeah, we're gonna test the coil or the sine wave. See if we get any wave. Does anybody know how to reset that to 0? The line on the oscilloscope? It's below the 0 margin, and I don't like that. Oh, we're getting some heavy spikes, dude. Like they're going all the way up. If we can get another one. One went all the way down. The hertz are going at 77.
Oh, make up our own language.
Huh? Man, you need to get a life, homie. Kicking.
Thank you for coming.
Man, I just don't understand. So there's a very slight wave there.
Oh.
Thank you, sir. Oh man, see, and it there's a well of gravity in here, and stuff like that makes it want to come out. Thank you, Chris.
I knew I was talking to him right away.
Yeah, you good. You were totally. He's at a yo. SSO.
There it is, phonetically incorrect. Oh.
Okay, that's way too much juice.
Yes. Oh, wake up to a pulse motor.
With a very smooth, fine sandpaper on it. You know? And then you just turn it on. At 700 RPMs, fine sandpaper will make smooth surface. Rub off all the calluses and everything, you know.
Yeah, the cows.
Now, this is 1 amp. Drawing 1 amp because these are 16 gauge coils. And there's only, let me think here, 750 turns altogether. Yeah, I don't know. I guess I lucked out. But I mean, there's so much wrong with this place that I'll take it with a grain of rice. This is definitely a pro, having your setup right there when you get up. But the fact that I need to buy a new roof and I don't have any money kind of sucks. Everybody looks at me funny here because my house is falling apart. I don't have any money to fix it up. Yeah, man. You fix house? We got bees, man.
Nice.
That's awesome. I mean, I can get fittings that fit together, but I don't have any experience in actually putting them together and like what kind of putties I need and all that kind of crap and how long the nails need to be.
Oh,
That's awesome, man. That's really good. And, you know, sewer work out here costs like 10 grand. Yeah, 10 grand, 500 to fix it. Yeah, it's like, screw you. You're charging me freaking 800 times what the job is worth.
oh man, I remember one time I was
What's up, buddy?
with my plumber buddy.
Sorry for yelling. I know I got this mic on.
Outside a restaurant, and we got a call, and my buddy took the manhole cover off, and this entire thing was filled with those little vodka bottle shots. And we looked at it, and the owner was like, "Oh my god, I know who this is." And then we told him, "Yeah, you're gonna have to call the city to come out there with one of those big vacuums, and then we'll help you out."
Hey, Caleb. Okay. All right.
And there's an area where birds have gotten in.
Yeah.
And there's some wind riding too.
And then my sinks are messed up. I want to get this bathtub out of my bathroom because nobody's going to use that bathtub.
His name was Mikey.
That's what acid is for. Yeah. So, I mean, the more I can get this one going way faster than it's going. I just hooked up the 16 gauge coils for torque purposes. So I could get it up to 750 RPMs like that.
It's right here.
What?
I'm wondering what that there is.
The coil?
Yeah, what?
It's 32 gauge. This one?
And that's a spool?
Yeah, this is a spool that you would buy from the store. And then you thread it onto a bobbin or a core, depending on what kind of adapter you have for your spinner.
Yeah, check out some of the coil winding videos. It's pretty cool how he does it. And he winds every single coil.
And this here is 5 pounds of 26 gauge. I think this is what I'm going to wrap the big gyroscope with. Use the coil. I'm going to use the coils to make the gyroscope. The big gyroscope with 26 gauge. And yeah, I'm thinking about using a receiver coil for the big one instead of a commutator. And have it be like up here. I don't know if that'll work. Now, what kind of cap should I use if I use a cap? And how should the cap be applied, especially if we're doing a parallel circuit with the coils? Thanks, Peter. Thanks, Carol. All right. Hey, can anybody answer me if this is a pot, right? This is a pot? Or is it just a speedo switch that checks the voltage?
Okay, 2 ice cream cones rather than pyramids.
So 2 cones.
So it's like there's that space in between that doesn't lock into the flat.
That's not what he's talking about.
You still have the cone.
He's talking about being rounded instead of being cornered. All right. So, and that would make a funnel, wouldn't it?
That is a pot.
Yeah. Okay, cool. So I have one just chilling right here. We could hook this up when if we need it.
Cool. Cool. Thank you for educating me. I'm learning more.
Yeah, because I noticed that the coils, they're not C-shaped, but they're made so that the energy focuses from like here and then comes up like that. So this is definitely not how I would wind the coils for the next one. I mean, I'd wrap them that way, but I'd definitely have a different bobbin. Unless, of course, they're designed to be solid. Are they solid? Are they solid copper?
Perfectly round and perfect.
Well, then it would be like, no. Kale, you're losing me, bro. Solid metal, right? That'd be solid copper.
Okay, so you're supposed to see the circle and the square from the top. Got it. And the circle would be
Oh.
on top of it.
So I get it. No. At the base in the middle, it's circular, but as it goes up, it's got edges, corners.
What's up, Bob?
What's up, Elmo? How's it going?
Yeah, I did know that. And he just asked for a synopsis.
Oh, all right. What's running right now is a pulse motor with 16 gauge at 120 degrees, and it is generating enough electricity to run 2 other pulse motors.
And then the video began featuring our gyroscope.
Yeah. So let me see if we can't get some love on this. So at 11.6 volts, that's what we get off of one of these coils.
Yep, that's the link. I think that's the link we were looking at too.
Yeah, no, it didn't. No, that might be a different one because the Utron, I never got a good glimpse of an Utron from the last link that you sent. This is the pulse motor I generated from.
Very nice.
Thank you, sir.
And collect.
All right, that was my original thought. So I mean, when I read through it, they mentioned 180 degrees and 60 degrees. They didn't mention 30 degrees. Oh yeah, well, I mean, I just judge from the picture, and then everything else is about the wiring and the connections, right? And how we're going to move the electricity around. So I mean, thank you.
Yeah, we appreciate
And I love how this thing likes to jiggle. It's solid. Thank
that.
you.
We appreciate that as well.
All right, so I do get it, and I don't. These are coils, right? You can't. I mean, when he said if it's not a coil where you can wrap with wire, he shouldn't call it a coil, right? I can wrap these, right? I can like take my 26 gauge and I can make coils in the shape of an Utron that will work, right?
All right.
Absolutely awesome, man. So cool. All right.
I feel like I got about 10 more minutes.
Okay. Okay. Yeah, I'm feeling good. 10 minutes is fine with me.
Wrapping Utron coil.
Well, I got an idea on how I can make it work. Yeah, super glue and patience. I'm actually going to make a bobbin that will help me.
Spin it right way.
Yeah.
Angles.
But the super glue thing is probably going to be a thing too, because as you wrap it up from the bottom, you start here, and this is going to be your south or your north. Power goes in, so it's the south. And then you're going to wrap up, and it's going to go out. And then you're going to wrap up and it's going to go in. So I mean, you don't have anything to lean on as you're wrapping, so you got to glue it or tape it. But I'm going to have grooves. I'm going to purposely make grooves, like stages in the bobbin, so it'll hold the wire. It'll help hold the wire in place. But yeah, I'm going to use wire that is definitely it's either going to be 26 or 24, so that it'll help keep it formed as I'm wrapping it. You know, 32 gauge would be really freaking hard to do, but this would be so, it wouldn't, I'd be discouraged. When you say a big cap, what do you mean? Is 275 volts big enough? Because I have a 275 volt AC cap. Yeah, well, we're going to have to do Bedini step by step because I haven't made one that was worth a damn yet. And I make a lot of coils. I haven't made one bifilar coil that was worked the way it was supposed to work. Not one. Yeah, I believe
This one. We test loads on
oh yeah, let me do that. I need to find my clip, my green. Where the hell did it go? Oh. There they go. What was I doing again?
big light.
Oh, the light, yeah. Let's see what we got. Okay, the ground. We're gonna feed off of this guy's loop.
This is where the magic. I can't believe we can got all the connectors memorized there. So now we have this one following this and that.
Don't touch the wires, Tiggs. Matter of fact, I'm gonna get you out of here.
Cat love. And then this one also has plugs in it around the fixture. So
See, 760 is, 750 is about what it goes. Doesn't really matter how much juice you put into it because it starts shaking. If I hold that still, it'll speed up, but when I let it go, it'll violently shake. So I think I'm gonna hook up like a 26 or a 24 gauge coil circuit, just to interchange with the 16 gauge.
Cool.
Awesome, Peter.
Say hello to Mama Hall Effect. Good question there. We do not have a commutator set up yet. That would be specifically by the magnets going by the switch.
Exactly. Since it's hooked up to this pulse motor's loop, the switch has to close for the light to be activated. You're welcome. Thank you, man. I appreciate everything. Great. I'm going to check out that video on the Utrons as soon as we're done here.
What up, Timmy? Thank you for watching our videos.
Thank you.
Your son is an excellent person and has helped us tremendously with our passion. He loves these things. Say hi, Caleb.
Hi.
Sorry.
See, when I turn, no, don't spin that. Okay. When I turned up the voltage to 16, let's get a tack reading on this. Excuse me, Caleb. Thank you. All right. I'm going to bet it's like 120. Nope, 99. 100, basically.
So you can kind of tell that as that red light's blinking, the
I put the cat out of here for a reason. So that definitely slowed down some. No, 104. Okay, speeding up a little bit. All right. Give that some time. I'll turn it down to like 15.
all right, man, I got about a minute left in there.
All right, I'll just turn it off then.
It's hot here today, guys.
Thank you. Thank you so much, everybody.
Thank you so much for dropping by. We are excited to be bringing you guys more lives and enjoy the collaboration very much. So thank you.
All right. Have a great night, everybody. We'll get back to you. Thank you very much. Come again. Peace out. Please subscribe. Have a wonderful night. Bye now.